Hi guys, today's session is about Electro-Pneumatics with PLC. So we'll be using two softwares, Codices and FluidSim. So first step is we need to set up both our softwares such that they communicate to each other. So we call that configuration. You open Codices, new project, choose standard project always, then your name or title, always your initials, surname, and serial number. Then OK. Under device as well as PLC, PRG, that's your language, you're going to choose ladder logic. Mine has it by default. And under device, you will have to choose control win v3. So if you have any other option by default, you need to really search for this and choose the correct one. Then click OK. From there, application, right click, add object, select symbol configuration. This you won't have it by default, but you need to enable it. Support OPC UA features as well as optimized layout. Then you select add. So we insert our add object and then click symbol configuration Y so that we are able to build. So when you click build, you will get three options, which are your symbols. The third option is your PLC code. So currently we haven't started coding or programming. So the third option we're not going to have, but enable the two that you have. Then don't forget to build again. Then you go to settings. We need to enable direct I/O access. Right. And then from here you double click under PLC PRG. This is where now we will insert our code. You double click. Let's go back to symbol build and check if it does appear. It doesn't, so we need to insert our code. So define your code. You're going to have your inputs and your outputs. On your lab guide you already have these variables, so you can just copy and paste. You copy and paste. I might also give you on the test, I might not, so just at least know how to insert or define one of your inputs, and then the rest you are just changing the name as well as the number. Okay. Before I insert my code, we are done setting up our codices to communicate with FluidSim. We are done setting up our codices. We forgot one thing. Under online, you select simulation. Then let's set up our FluidSim. So already I have my power supply, which are my 24 volts, 0 volts, compressor, a service unit. Under options, there's 3 steps that we need to follow to configure or set up our FluidSim to communicate with codices. You go to options, select easy ports, then enable OPC mode, enable event buffer, then select OK. Second step is we need to insert a new component. We need to insert a new component under easy port or PC DE. So that is our FluidSim out and our FluidSim in. This is how you need to place them all the time, like this. So second instruction, you double click under FluidSim in, then under items, that's where we need to change our item or route to virtual PLC since we are working with PLC. Then this side we'll choose AB1. However, you need to change that and insert 0 instead of 1. So all our variables, whenever we define them, will start at 0. So hence we choose that our FluidSim in, it is AB0 and not 1. So under FluidSim in, we change our item to virtual PLC AB0. Under FluidSim out, we double click, you repeat the same process. Virtual PLC, instead of choosing AB, you choose AB1, but we have to change it. Capitalize your EB and then 0. Then you click OK. Double check all the time if here it's APO and here it's EPO, because if you swap them around, then your circuit will not simulate. So we are done setting up our FluidSim to communicate with our codices. Then this EZOPC will appear. This is where you need to check the version number. You go to codices, settings, codices, check codices version, V2 or V3. If it's at V3, then you click OK. If not, you select V3. Don't close, you just minimize. So we're done setting up, and then now it's time for us to insert our code. I'll type mine. Okay, since I don't have the lab guide, I'll copy this, paste. Okay, I have I2, I3, meaning this must change as well. My stop push button and my emergency stop. So for PLC, since you work with big machines, you're gonna need to insert your emergency stop as well as your stop. So usually PLCs, they come with these 3 buttons: your start push button, your stop push button, as well as your emergency stop. In case of any bottlenecks that you are having in that particular station or machine or robot, you always need to insert your push button in your code, your stop button, as well as your emergency stop. So this is a basic code that we will work on, and then our outputs, they are represented as Q's. So Q0, then we change this I to Q, and our inputs are our push buttons as well as our proximity sensors or switches, and then our outputs, this is sorry, where you insert your solenoid valves. We're done inserting our code. The next step, what do we need to do on codices? We need to build our ladder logic diagram. So this is where you build your ladder logic diagram. You have your contacts as well as your coils. I did explain on the previous class what is a coil. So that's where you insert your output, and your contacts, those are your inputs. So most of the things I'm not gonna put emphasis because I already did in class. So this contact and this contact, they are one and the same thing, right? It's just that this one, it says you insert on the right, and this one you insert where you have clicked. And then this one, it is a negative contact. Both these are a positive contact, which I did teach you guys the difference when to use the negative or positive, but I'll put emphasis as we move from this exercise to another. So we insert our coil, our contact, which is I0, and then we insert our output, our coil, that's Q0. Right. So this is our basic ladder logic diagram, and our FluidSim circuit should run with just this basic diagram, ladder logic diagram. However, because our PLC, we always need a stop push button and an emergency push button, we will have, even your test, you will have to insert those 2. So just, I'm gonna click log in. Okay, before that, let's log out and check if we've built. We didn't. So when you click build, that third option or symbol has appeared, and we need to enable it. Then we build again. Build again. Click log in. Now we are logging in so that we can simulate. Play. Right. So this side, we don't have our components on our electric as well as pneumatic circuit. So our pneumatic circuit, Your lab guide has different exercises, I think exercise 1 to 6. Please go through those exercises and try to build based on those statements. I'll try to also read those problems as we build, but I want you to grasp the concept of what we are doing, each function, the function of each component, and when to apply it in what scenario. So I don't want you guys to cram the exercises, but I want you guys to understand the function of each component, as well as when do we apply a spring return cylinder, a double acting cylinder, and so on and so forth. A 5 two-way solenoid valve, a 3 two-way solenoid valve. So we're gonna start with the single acting cylinder. So normally closed. Why? Because we are advancing our piston rod. Double click on your solenoid valve to label it, give it the same name. We're gonna call it Q0. Okay, we are done with our pneumatic circuit. Now let's build our electric circuit. Our electric circuit, we have our code, we have I0. Okay, let us stop and log out. We have I0, I2, I3. I0 our make push button, I2 our brake push button, I3 our detent brake switch. So this is our I0, our make push button. Label it as I0. Make sure that your work is quite neat. Then our stop push button, we use our brake push button. Let's call it what? I1. Then our detent brake switch. So this is our emergency stop, meaning that when you stop, when you click your emergency stop and you try to restart your process by clicking the push button, it will not start. Right, this is applied in most cases when there's bottleneck issues and they need to stop the machine from working and maintain it or fix it. So it is also used also maybe when there's a breakdown in real industry, in industry, or in a real life of a mechanical or industrial engineer. Okay, so we have both of these, and then for electro-pneumatics with PLC, we're only going to be doing direct actuation, not indirect. So we know that direct actuation, we need a valve solenoid. It should be directly connected to a push button. So in this case, the connection needs to be like this. So your valve solenoid, it connects at 0, FluidSim in. Then we give it a name. It's our output, which is Q0. So let's check this side. Yes, we have all 4 components on FluidSim that are well represented on codices in this coding language. So I0, I2, I3, Q0. I0, I1, our detent or emergency, we didn't name it. It should be I2. This is Q0. Then our ladder logic, so we just created a basic one without I2 and 3. It should still function without. Then I will show you how to insert these 2 stop buttons after. So if we were to give this a scenario, we would say when you click your push button, your piston rod needs to advance. When you release your hand from the push button, it must retract automatically. Why is it retracting automatically? Because of the spring return on the acting cylinder as well as on the valve solenoid. So let us test it out. I click my push button, the piston rod advances. I release my hand, it retracts automatically. So this is exercise 1 on your lab guide. Yes, I think this is exercise 1 on your lab guide. So this is exercise 1, and the ladder logic diagram doesn't include the emergency stop and stop push button. Let us add the emergency stop as well as the stop push button. So that is our I1 stop push button, and then our I2 emergency stop push button. Any changes that you make on your ladder logic diagram or your code, you always have to go to symbol configuration, build, and then enable your PLC, because you have revised your ladder logic diagram or code, then build. Go back to our code, log in with download, play. We should achieve the same results. Okay, stop. Okay, play. We are not getting the same results as... Okay. Okay, let's read exercise 1. Half-liter cans are filled with wall or ceiling paint at a manual station. The lids are press-fitted with a pneumatic press. The cans are manually inserted into the press. After pressing a push button, the press cylinder is advanced and the lid is press-fitted. When the push button is released, the press cylinder remains in the advanced position. When the push button is released, the press cylinder remains in the advanced position. Okay, so on your lab guide, actually the previous exercise that we've done now, you don't have it on your lab guide. But exercise 1 is actually this one, where you create a latch where it says when you press your push button, your piston rod must advance. When I release my hand from the push button, it should remain like that, right? Only when I press the stop button, it should return to its retracted end position. So, okay. So this exercise is not on your lab guide, but we can still achieve the same results, and then we do this exercise. So you stop, you log out, and then I'm not sure why this thing is not running. Let's check our code. 0.0, 0.1, I3 it's 0. Okay, so our code and our ladder logic diagram doesn't, okay, it's not adding up. Our I0, we have I0, I1 and I2, so it's I1 and I2, 0.1, 0.2, I0, I1, I2. Okay, before anything, let's build. Right, we need to remove now I3 because we don't have it. We no longer have an error. So when one of these symbols are highlighted in red or the font is in red, it means you have an error and you need to fix it. So what do? You click on this plus sign, then you will see it will tell you where the error is, and you are able to resolve it. You build, come this side. Our code seems fine. Okay, log in with download. Okay, play. When we press our push button on FluidSim, it should advance, and then when you release your hand, it should retract automatically. Okay, I click my push button, it advances, the piston rod advances. I release my hand, it retracts automatically. So I was just showing you the difference, how to achieve the same results, having the most basic ladder logic diagram that doesn't have your stop buttons. So now we have introduced our 2 stop buttons in series, and we achieve the same results. So we move to exercise 1, which I've just read. So exercise 1, ceiling cans. So the problem about the problem description: half-liter cans are filled with wall or ceiling paint at a manual station. The lids are press fitted with a pneumatic press. The cans are manually inserted into the press. After pressing a push button, the press cylinder is advanced. So after pressing a push button, the press cylinder is advanced and the lid is press fitted. When the push button is released, the press cylinder remains in the advanced position. It doesn't retract automatically. The cylinder will only retract when the stop button is pressed. Either I'm pressing the stop button, which is I1, or I'm pressing the emergency stop, it should retract. The sealed cans are removed manually. Okay, a single acting cylinder should be used. So we are not changing a lot of things. You stop and then you log out. Already we have our start push button, our stop, and our emergency stop. So our diagram determines our description of the process. We should changes then our ladder logic diagram. So whatever scenario you're given, you need to check your ladder logic diagram, how you've connected your contacts as well as your outputs. Then that will define how your piston rod will be advanced and retracted. So looking at this in series, it means this is a one-way process. I click here, it advances, it retracts automatically. But now I want to create two different processes. So when I create two different processes, I need to then insert a latch or create a loop. So how do I create a loop or a latch? I then say insert a contact in parallel below. So I'm going to insert a contact below. This contact will be my Q0. Representing what? My valve solenoid. So why are we doing this? We are separating this ladder logic diagram into two processes. So this loop that we've created, we're basically saying this part of the diagram focuses on advancing the piston rod. That part of the diagram focuses on retracting the piston rod. So what are the components that we use to advance the piston rod? We use a push button, which is presented as I0. What do we use to retract? We use our stop push button, our emergency stop, hence it's on the other side of our ladder logic diagram. So from here, what do we do? Simple configuration, build, okay, build again. And then nothing changes this side. The only thing that changes is the process. But every component, all the components that have been connected here, they don't change. The setup doesn't change, only the process or the method of advancing and retracting changes. So we are creating a latch, meaning that this piston rod must remain at this particular position, which is advanced, until another push button is pressed to retract it. So let's select, okay, so let's come here, check if it's VIN 3. It is VIN 3. Come here, did we play, did we log in? We haven't logged in, so that's why it's not simulating. So you click log in with download, okay, play, and then go to FluidSim. So I click my push button, release my hand, the piston rod is still advanced. Then I click a stop button, it should retract. So I want to show you the difference between the emergency stop and just a stop button. So I click my push button, advances. I click my stop, it retracts. I click again, it advances. Then I'm gonna use my emergency stop, which will not enable us to reset our piston rod to advance our piston rod once again. So I click this emergency stop, then this arrow shows that it's been activated. So for as long as this emergency stop has been activated, when I restart my process by clicking the push button, it will not start. Why? Probably there's a machine breakdown, and until that process has been completed, then the machine will be able to be reset. So let's click the push button. It doesn't work. So that's the difference between your emergency stop and your stop push button. So now I want to show you how to, so we were able to then still use a spring return acting cylinder with a solenoid valve that has a spring return, and we were still able to achieve a latching circuit. We were still able to advance our piston rod without automatically retracting it by means of a spring return effect. So there's many ways of developing a circuit to fulfill just one process or purpose. So now we will use another way. So here we used this to advance, that to retract, or that to retract. So another method now, which we're gonna use a double acting cylinder. Let's check exercise 2. Okay, exercise 2 reads as follows. Packages will be diverted from one conveyor to another by means of a diverter. The diverting gate is advanced when the start button is activated and when the cylinder is in retracted end position. So meaning that we are told that it should be at a retracted end position, we need to introduce a sensor, a proximity sensor that will sense the retracted end position before we start. When the cylinder is in the retracted end position, to ensure that the boxes are properly diverted, the diverter gate is returned to its initial position when a stop button is activated. So same process, we are just introducing a sensor. So let's use a magnetic proximity sensor. This is our magnetic proximity sensor. We will connect, usually this point should be connecting to a relay if it's in direct actuation, or a solenoid if it's direct. So in this case, okay, I want it to be as neat as possible. This will then connect to FluidSim out point 3. We're defining it, we're going to say I1. So we are introducing a double acting, okay, no, we are still on a single acting cylinder. We need a ruler because we have a sensor to define our position, which will say it's I3. It must define position 0 to 0, which is the rear end position, our I3. This is our I3. Okay, so this arrow shows that already the position has been detected, which is the rear end position. What changes this side? Stop, lock out. What changes this side? Or what do we add? We then gonna add I3. Okay, so I3, we need to add I3 here because this is a condition for our push button to be actuated. For our push button to work, we need to detect the position, which is I3. So this is an AND operation that we have just created here. We are saying I3 must be detected for us to activate, for the push button to be activated. So these two components are for advancing our piston rod. These use either of the two to retract. So our code, we are done with our ladder logic. We've added our code. We need to add I3. A sensor is an input, so hence we are adding it this side. Change this to 3, and then you can either say sensor 0 or proximity sensor or S0, whatever name makes sense to you. Okay, so from here we need to then build, enable PLC, build again. log in with download, play. Right. Okay, when we click our push button, same process. We click our push button. The only difference is that this proximity sensor, it senses the rear end position. So the process remains the same. When we retract, we use this. We use this again. When we retract, we then use this emergency stop. And when we reset, it won't work because we've just inserted our emergency stop. So every time your piston rod goes back to its rear end position or retracted position, this proximity sensor will have this arrow showing that there's power because it's been activated. Then you start your process. Or we've selected emergency stop, hence it's not restarting. So when we start, it's at its fully advanced position, hence the sensor doesn't have any arrow and any power flowing, because it only senses or detects the position at 0 to 0. Okay, so let me check the next exercise. That was exercise 2. So exercise 3, plastic pellets need to be filled from a storage silo. The silo is opened and closed with a flap. The process will be started from 2 locations. The flap is opened by pressing either one of the 2 push buttons, and the bulk material is emptied out of the container due to the cylinder advancing. When the stop button is activated, the flap is closed as the cylinder retracts. So it is the same process, however, we start from 2 locations. So we have 2 push buttons. I'll just gradually make our circuit to be complex. So other items that are not included on other exercises, it doesn't mean it's a memo that, it doesn't mean this is the memo, but listen to my explanation and where we are. So the exercise, the problem statements are just there to help us picture the process. So from here, we want to see how we can still advance our piston rod using a push button and retract using a stop, but now using a double acting cylinder. So we want to see now when we use a double acting cylinder. Also, how do we know we need a double acting cylinder? We are told that we have 2 push buttons. So we start the process using 2 push buttons. So we need a 5-2-way without a spring return. Or do we need a 5-2-way with a spring return? Let's see if it's achievable. It is actually achievable with both. Okay, our previous exercise. This is our previous exercise. We will remove this. Okay, we'll remove this proximity sensor because exercise 3, we don't have a sensor, but we just start the process from 2 locations, from either. So we need another make push button. This is our make push button. And yes, because both of them, we use them to advance. If the question was to say, this push button must retract, must do the same job as these stop push buttons, then perhaps we would then have another valve solenoid connected to FluidSim in point 1. Okay, so we have this. You can give it a name. I don't want to call it I something because it's gonna confuse you. You'll think I've added a variable on codices. So I'll just say PP2. It's my extra push button. So this extra push button, what role does it play on codices, or Does it mean now we will have to insert another code that has push button number 2, or our code will not change, only the components that we have will change? So yes, our code will not change, it will remain the same. The only thing that will change, okay, we have two ways to present this. We have edited there, nothing changes on our code, meaning that nothing changes even this side on our ladder logic diagram. So log in, play, let's see, simulate, stop. Okay, we need to change because we no longer have a proximity sensor. So this I3, we need to remove it. We don't have a proximity sensor, so we need to remove it. System build. See, we have removed I3, so let's disable it. Then build again. I think now it should be fine. Okay, play. It advances, click the side, it retracts. Let's try push button number 2, it should do the same. If it's not doing the same thing, then something must be wrong. Okay, so we have 2 push buttons, and we haven't changed anything on our ladder logic, we haven't changed anything on our code. We still have I0, I1, I0, I1, I2. We don't have what may be I4 or the last push button. I0, I1, I2. Okay, so we need to introduce this push button. Let's call it I3. I3. This is I3. Something must change on codices as well. We can't have I3 there and nothing happens here. So we are saying we either use this push button to start the process or that push button. So our AND operation, remember, it is a series connection. Our OR operation or OR gate, it is a parallel connection. So we're going to click our IO and then insert a contact below in parallel, like that. This contact becomes our I3, which is what our push button number 3. So it becomes I3, I3 being our push button, our second push button. So change this to 3, this to 3, and then copy. This becomes our second push button. I'll say push button 1, this is push button 0. So I have my PP0 and my PP1. So my push button 1 is I0, my push button 2 is I3. I have that here. My network or ladder logic diagram, I have my I3. This is a what? An OR gate or OR operation. I can use either I0 to start the process or I3 to start the process. So let's go to system configuration, build, then enable PLC, build again. Log in, download, start. Okay, so our piston rod, or rather our circuit, should function properly. We need to, what is this saying? I3. Oh, okay. So we need to remove this ruler. Remember, we are building on the previous exercise. So the distance ruler was for us to program the sensor. So we are no longer using any sensor, we don't need the distance ruler. So this is our I3. I click this push button number 1, retract with the stop button, or I use this push button and retract with the stop button. See, so same function. Then my emergency stop, when I click it will not start. So guys, I hope you understand. Now we will move to exercise 3. So we have 2 push buttons, but we don't need a 5-2-way because both of these push buttons are for the same function, to advance our piston rod. If we were to use a 5-2-way without a spring return but with 2 points for our valve solenoids, then it would mean that this side or this push button would be for advancing, the other would be for retracting. Actually, let us just, out of interest sake, let's just test that out. Let's test that out. This is my Q1. So we are saying, out of interest sake, we want to see if we were to use a double acting cylinder and have these 2 push buttons performing a different function, how will our circuit be? So of course, then this means our ladder logic diagram must change, because this is an OR gate. So it means our I3 will come this side now. I3. I'm just testing this out. I didn't even prepare it. Just wanna see. Okay. This better work. Okay, so why? Why is my valve solenoid like this now? Errors occurred during code generation. See message list. Okay, error. Where's another one? This I3, it's my stop for retracting. Okay, no. Okay, we leave it. It didn't work. Let's focus on the stuff that we have prepared. Okay, so we are from this exercise, which is exercise 3, where we have 2 push buttons. We either use this one to advance or that one to advance. Okay, so exercise 4, optimizing the inspection of beverage crates. The statement is too long. I'll only read the description of the process. The cylinder of a piston rod should advance as soon as push button is activated. After the piston rod reaches the front end position and activates a magnetic proximity sensor, it should be retracted automatically. It should be retracted automatically. Okay, so we are introducing the previous exercises. We introduced a proximity sensor that was sensing the rear end position. So now we are inserting a proximity sensor which needs to retract automatically the piston rod to its rear end position. So our I3 becomes our sensor 0. Okay, we introduce Q1. Why are we introducing Q1? We will be using a double acting cylinder. Already I have it in place. We are using a double acting cylinder, our 5-2-way without a spring return. We need a distance ruler. Our I3 at 100. The piston rod must retract to its initial position. So this we don't need. What do we need? We need our proximity sensor. We need our proximity sensor. We call it I3. Right, so this Q1, we have introduced it, or this 5-2-way without a spring return, we've introduced it because it is for the retracting position. So this side is for advancing, this side is for retracting. So this side we are using a push button to advance our piston rod, and this side we are saying this magnetic sensor, it needs to detect when the piston rod is fully advanced and automatically retract it or return it to its initial rear end position. So this is for advancing, this is for retracting. So with the single acting cylinder, we wouldn't be able to achieve this process because the spring return of the single acting cylinder would return the piston rod to its rear end position automatically because of the spring. But we don't want the spring to return it, but this sensor, we have programmed or coded it to return it automatically. So our code, yes, we have our sensor, stop buttons, start buttons, our Q0 and our Q1. Then this needs to change, our circuit. So our ladder logic diagram needs to change. So our ladder logic diagram, this is our push button for advancing the piston rod, our emergency stop, as well as our push button stop. So we need to introduce what? Our sensor, which we gave it a name, we said, or a label, we said we define it as I3. So I3 must sense the fully advanced position. So now we need to do what? We need to introduce Q1. So Q1, okay, Q1. So we're now going to introduce a new contact and a new coil, right, which is a negative coil and a negative contact. So this sensor is a positive, right? This coil is a positive. Everything is a positive contact, a positive coil. But because this sensor needs to be on, we then need to apply negation or negation method, or you can just say insert negated contact and remove this one. So negation is basically us inserting this line to show that we are closing this contact such that it becomes activated, it receives power. Because when it's opened, current can't flow, it can't receive power. So we are inserting a negation process, or we are negating it to enable it to be on. Because if it's not on and it receives power from the second valve solenoid, which is not activated to when initially we start the process, then it won't be activated. But the sensor that we use to detect the rear end position, it doesn't need to be negated, because already the push button that we have here, when we click it, it closes, and then it allows power or current to flow through the circuit. So as we change the sensor, we also come to this coil, which is Q1, then we also negate it. It is a principle. So when you have a sensor that advances or detects or senses the advanced end position, you need to negate it. Even your Q1, you need to negate. They go hand in hand. So from here, system configuration, build. Excuse me, I always make sure that I build twice because I don't want any mistake. Then from here, log in. Now we want to simulate. Start. So you see the blue line here. It shows that we are saying this should be active. This should be true. We want it to be activated so that it works. So let's go to double check here. Localhost, yes. Let's simulate. When I press my push button, it should advance, and when I release my hand, it should retract automatically because of this magnetic sensor. Yeah. So it does exactly that. When you insert a one-way flow, you'll be able to see how fast it's moving to advance and retract. You can even play around with it and say you want it to advance slowly or to retract faster. So yeah, it advances and retracts automatically. When I advance, my I3 becomes activated. There's an arrow that shows, and current, it becomes this. You see these lines and these lines are not the same. This is a light, or yeah, it's a light red, and this one is bold or dark. So this one shows that there's current, and here there's no current. So when I click here, there'll be current when it advances, when it reaches the fully advanced state. Yeah. Okay, so then I'll then build a circuit where we need to detect both positions, the retracted and the advanced. So I'm mixing the two exercises. The previous one where we were only detecting the advanced, the rear end. So now I want us to detect both rear end as well as front end position. So I'll call the rear end position I3, and then the advance, I'm changing it, I'm gonna call it I4. Okay, so I3, 0 to 0. I4, 100 to 100. That's it, 100 to 100. What you do on your FluidSim, you should also do on codices. So I've added a second sensor. I must add on my code. It must change on my ladder logic. So it's my I4, sensor 1. Right, so this becomes my I4 now. And then here I need to sense the rear end, so I insert my I3 here. System configuration, build, PLC. It seems like everything is well presented or demonstrated. My rear end position detector, my front end position detector. Play, already my rear end position sensor or detector, there's current flowing to show it's active. So meaning the piston rod is at its rear end position. So I click my push button, it advances. Then when it's fully advanced, my second I4 will have the same arrow, and these lines will be dark red or bolded to show there's current flowing when it's fully advanced. So guys, you should know how to detect the rear end as well as the front end position. Whatever that you do, any new components you add on FluidSim, always know that you need to check your code, you need to check your ladder logic diagram, they need to speak the same language. Okay, so that was exercise 4. Did we read it? Yes, we did. The cylinder of a piston rod should advance as soon as push button is activated. After the piston rod reaches front end position and activate a magnetic proximity sensor, it should retract automatically. So what we added on the exercise is to say we also want to detect the rear end position. So it's important to read the statement because you can advance and retract in so many ways, but what restricts you, it's the statement. How do I advance? How do I retract? Okay, so we've done exercise 5 as well as exercise 4. So exercise 5, what we've built now, having 2 sensors, that's exercise 5. It reads as follows. Bottles need to be diverted in groups of 3 from one conveyor to another by means of a diverter. After being switched on, the system should run continuously. It should not be switched off until a stop signal is generated. The sequence is started by pressing a push button. If 3 bottles are present, the retracted end position. If 3 bottles are present, the retracted end position, the diverting cylinder's piston rod is advanced. The bottles are diverted and transported to a second conveyor belt. The sequence is stopped by pressing a second push button. Okay, exercise 5. We are testing if 3 bottles are present, so the rear end position is being detected or sensed, so which is what we already have here, this sensor. And then the bottles are diverted and transported to a second conveyor belt. The sequence is stopped by pressing a second push button. Okay, no, this is not exercise 5. Exercise 5, the piston rod doesn't retract automatically. It doesn't retract automatically, but a second push button is the one that advances the piston rod. Okay. So the solution that you have on the lab guide there, it's not a true reflection of the actual statement that we have in exercise 5, because exercise 5 doesn't automatically retract. It says you need a second push button to retract. But the memo that we have there is this one, so it's not the same thing. I hope you are reading through your statements and challenging the statement. Why am I having 2 proximity sensors while my statement only says I retract with another push button? Okay, so let's check the time. I think these basic exercises we are done. This is our last exercise. I will upload another video where I'm inserting a timer, or let's just let me check how long is the video. Okay, 59 minutes. Okay, so we can still go on and introduce a timer. Our video is an hour, so we can introduce a timer. Just 2 more exercises and then more complex more complex exercises with a timer I will upload after this one. So we stop, you log out, then let's introduce a timer. How do we introduce a timer? On FluidSim, we don't include any extra component. We don't. The only way to introduce the timer is through codices. So we're going to insert a second network. You click here on your network, then you say insert network below. We are inserting a timer. So I'm going to show you how to delay. Basically, the timer that we are inserting, we are delaying the advancing process or the retracting process. So I'll show you how to delay the advancing process as well as how to delay the retracting process. So we are saying this push button, it should start to advance the piston rod after 5 seconds. So I'll click my push button and it should count up to 5, then the piston rod should be advanced. So that's what we are trying to implement. We have inserted our network below. Then under function blocks, we're going to choose this function. This function, a monoflow function block with dominant set. So we're going to choose this function. Okay, we're gonna drag this, and where it's written start here, you drop it. This allows us to insert our timer. So this is a setup. This is a setup for our timer. So turn, this is our timer, or a timer on delay function block. So we repeat the same process. You drag, you drop where you see a green arrow or a green diamond shape, and then you drop it there. Okay, lastly, you click here to insert we always need an output. So you will always have your coil at the end, because these are your inputs and this is your output. So you're always going to have your coil there. So what is my input? What is our input? What do we use to set or to start the process? So this we have set and we have reset. So we start our process using our push button presented as I0, and then we reset or we retract our piston rod using what? Using this magnetic sensor, which is I4. Our piston rod advances automatically using I4. So this timer, we could insert it in any other scenario, but because this is our last exercise, we're going to use it to insert the timer. Okay, so we reset, it's our I4. Our I4 automatically retracts our piston rod. Our I0, it advances our piston rod. Then here, we're just going to say SR_0. Here we're going to say turn_0, and then here we remove these question marks. Then here, this is where now we code our time, or we program our time. Capital letter T, hash, the seconds of the delay. You want the delay to be 5 seconds, 10 seconds, what? So 5 seconds. The 5 is 5 seconds, and then I write S, small letter S, to represent my seconds. So it's T#5, small letter S. So the time delay is 5 seconds. And then our output, usually our output is our solenoid valve, but when we insert our timer, our output becomes a memory. So that memory, we say it's M0. That's our first memory, it's M0. So now we need to change our initial ladder logic diagram, just a small change. So we are saying, before we click, when we click I0, before our piston rod advances, it should count 5 seconds. So this memory, we need to insert it here. So our I0 becomes M0. We are saying this I0, it needs to memorize the 5 seconds delay before the piston rod advances. So this memory 0, we are saying this is a code, so this plus this is equals to that. This make it to be equal to this. Okay, system configuration build, in case there's anything, double build or build again. Then log in. Okay, before I log in, I want it to be a double screen. Okay, it will not, I'm not sure, since I'm using one screen. Okay, but okay, we are on codices, so you log in with download. Okay, there's an error. What error? Log in with download. Error occurred during the code. See on the list. Okay, so we must always double check if we have our SR, our TAN presented under our code. So if we don't have it, we might need to put it manually. We might need to insert it manually. But usually when I insert my code, it changes also. So if it doesn't change, then I need to insert SR underscore 0, right? Okay, this, I need to insert my code, TAN underscore 0. TAN. Then my memory M1. Cool. So it should work now. Should work. Build. I don't have any error. I believe I don't have any error. So I click play. Go to FluidSim. When you click your push button, count up to 5. Then after 5 seconds, your piston rod will advance. I click my push button. 1, 2, 3, 4, 5. Okay, I was too slow. But yeah, so you click your push button. 1, 2, 3, 4, 5. It should advance and then retract automatically. So that's our delay. So our on delay timer. We have delayed the actuation process. We have delayed the advancing process. So let us now delay the retracting process. Stop and log out. So the retracting process, how do we delay it? What do we use to retract? We use the push button to advance, right? So what do we use to retract? This, our I4. Our I4 retracts our piston rod automatically. So then to set our timer, we need to insert I4 there. Excuse me. We need to insert I4. Then after inserting I4, here we need to insert our contact, right? Okay, so our I4. Okay guys, before I expand my diagram, we forgot one thing. So we didn't insert under our timer, we didn't insert our break as well as our stop button as well as our emergency stop button. So we need to always have those presented also here. So how do we do that? We insert them in parallel below. So we insert them like this. So this becomes our I1, which is our stop push button, and then our I2, which is our emergency stop push button. This. So we have I0, which is presented as MO, memory 0. We have I4, which is this, I1 that, I2 that. So whatever that you have on your ladder logic diagram, you must also have when you are rebuilding your memory this side. So what's new? I forgot to mention that our I4 this side, we don't negate it because it's gonna make us to keep on restarting the timer. So we don't negate it when we insert the timer here on this graph. It's actually the opposite. So the items or the components that you negate on your ladder logic this side, you don't negate when you insert your timer. The ones that you didn't negate, you have to negate when you come this side. So it's, then I'll say negation, click negation. That's it. So I want to delete this and show you that you can insert a negated contact right away and not negate. So here's a negated contact instead of clicking negation afterwards. Then this is my I1, this is my I2. Okay, system configuration, build, come this side, log in, play, FluidSim, stop and simulate. Okay, what do we have on? Yeah, it should work. Okay. Oh, it's delaying 5 seconds. 1, 2, 3, 4, 5. Should advance. Yes, and come back. So the delay has been achieved. Let's do it one more time. 1, 2, 3, 4, 5. Should advance. Yes. So the process, we've achieved the process. We've inserted our timer and it takes 5 seconds. I want to show you, I'll click because when I split, you won't be able to see both my FluidSim and codices. Now I want you guys to pay attention to what to the timer on codices. I'll click my push button, then quickly go to codices to check the timer. Look at the timer. See? There we go. So okay, log out, stop and log out. Now I want to introduce a timer for doing what? For delaying the retracting position, the retracting process. So the retracting process, we said what retracts the piston rod automatically, it's I4, which is magnetic proximity sensor, the second one at 100 to 100. And then here we have now our I1 and our I3. So our I0 and I3, these we use them to advance. So this is our sensor, our proximity sensor that detects or senses the rear end position, the retracted end position of the piston rod. And this, it is our proximity sensor that detects or senses the fully advanced front end position of the piston rod. So this is how we then create a delay. Our set, it is I4 because we use this I4 to retract, and then this, it's under reset because we use this to advance. So we want to start over the process, we use this. Then this is my brake push button and my detent brake switch, which is my emergency push button and my emergency stop button and my stop button. So nothing changes on your code because everything that you have here you've defined here. But my memory now, I need to insert my memory not on I. Remember, this is I0. So my memory goes to I4 now because I want the delay to be right before I4 is activated. So my I4, it changes, then it becomes memory 0. Okay, becomes memory 0. Then from here, our delay should be at the retracting process. So let's check our FluidSim. We want to delay the retracting end position. So this, it will not delay. When you click your push button, it will immediately advance. But when it comes to retracting, it will latch a bit for 5 seconds and then it will retract. Let's test it out. Okay, we forgot to play. So we forgot to click play. 1, 2, 3, 4, 5. It should go back. Yes. So let's do it again. 1, 2, 3, 4, and 5. It should go back. Yes. So we have delayed the retracting process. So we'll now pay attention to the timer. It has advanced immediately. Let's quickly check the timer. And it retracts automatically. So guys, I think this is enough for this video. The next video, I'll be the next video will be only introducing timers in a complex not in a complex circuit, but it's basically, here we have done a retracting, a delay for advancing and a delay for retracting. So the next video will be on having a timer for a circuit that runs continuously. So yeah, that's it guys.